Welcome guys, let's get started with coding the linked list, and we'll discuss the usage of pointers here. And once we're done with that, let's just go ahead and create the linked list that we need. So let's talk about the structure of a linked list. So here a linked list actually looks somewhat like an array. So it's an array like this, but the thing is, since we know that it is distributed in different places according to the RAM, we know that it basically doesn't know where to go. So there is a small component in this storage that tells us where to go next. So let's just say we represent our data by something like this, and we have a pointer to the next place, which is represented by something like this. So this is actually the reference to the next node. So let's say the storage space of this one is 1, and the storage space of the next node is somewhat like this. So let's go for this node. So what's here is this value, right? And what's here is let's say there's another node at this one, and we have a different node here, and this stores this number. And here let's say we are at the last node. So the last node has to store a special thing known as null, which is also known as the escape 0 character, and this stores the null character. This is important because it marks the end of the list. So let's just go ahead, and once we have understood all this, so we know we need a structure that can hold two numbers. So let's create a structure of a node, and it contains two things: an integer value and a node pointer to the next node, right? Let's just also create a constructor for this. It takes an integer value and integer v, and it just initializes the value and sets the next to be null or null, right? So that's just the basic code for our structure, and let's just go ahead and use this one now. So let's just say what happens. So let's create a linked list class as well. So let's create a class called linked list, and in this class we have the following operations. The first operation is addition of number. Then we have another use case that we can apply here, that can be the the printing of the whole list. So let's just create this linked list class containing these two functions. So let's create something known as a node head and a node tail. Okay, so what is a head and a tail? So it is very much like a body, or let's say this is a linked list. So since this is a linked list, this node here is known as the head and this is known as the tail. So the thing to remember here is addition of nodes happens generally on tail. Why? Because it is the easiest to do here. What is happening is this is pointing to null. So null is an address that the complete thing, that the RAM does not know at all. So when you change this, you add another node here. Now this node becomes the tail and it is pointing to the null. So you can easily add stuff to the tail, whereas if you wanted to add something here, the reference to this one to the previous tail has to be changed, or anywhere inside the complete linked list it has to be changed, so the references need to be balanced. We'll see that as well, but for now let's just assume that it generally happens in the tail. So 1 3 5 7, somewhat like this, and you can add for now only in the end. So let's just write these functions down as well. So let's create a constructor first of all. So the constructor is the basic constructor, and it's gonna just initialize everything to null. So it's gonna make the head null as well as the tail null. That is the initial step that the constructor performs. Now we need to add nodes. So let's just call the function add, and let's say it returns void. And what it does is that if head is null, that means our linked list is empty. So if head is null, what you need to do is initialize head and tail. So what you are adding here is actually a number. All right, so if head is null, head is a new node initialized by the value that you gave it, right? And tail is also right now pointing at the head. That's all right. And if that is not the case, then tail, so there's a new node, let's call it node, new node is a new node with the value val, and tail is actually pointing. So the tail's next becomes this new node, and tail becomes this new position that is created, and this is how addition works here. All right, and also let's create a function to print the whole list. So void print, and what it's gonna do is while head, so let's create a new, so let's create a node temp, right? And let's initialize it by head. Let's just go ahead and put it here. So while temp is not equal to null, while temp is not equal to null, what you're gonna do is you're gonna say print temp value. And so let's just do this. So cout temp value, and let's put an arrow after it, and in the end let's just go for a cout null handle, and it's gonna be a string that says null, not null, because it cannot actually be printed or something. So let's just go ahead and see what happens in this case. So it's just gonna print all the values and move the pointer every time. So what it's doing is pointing at the head, going to the next value, printing it, and so on till the value becomes null, because we have kept it as the end of our discussion. So that sounds good, and if that's enough, so let's just go ahead and try out our linked list. So let's create a linked list. L to L let's add 1, to L let's add 14, and to L let's add 19, and let's print this linked list out. So let's see what happens in this code. So let's just go ahead and compile so that we can run this out. So G++, it's going to be a linked list CPP, and let me increase the size of this thing. So it says something is yeah, so it's going to be a pointer, right? So let's go ahead and see. Okay, so well, so these are actually pointers. Both of these are actually pointers, and also so new node is actually a pointer as well. So where's new node? New node is a pointer as well, right? And I think this should do. Okay, so since we're done here, so let me just increase the size, close this down, clear everything out first, and let's just compile and run everything. So yeah, so there's a problem here, so let's see what the problem is. Let's go for Sublime linked list.cpp, and what we are doing is we're not assigning this out, right? So I think this should do it. Let's clear stuff out first of all, then let's go for compilation, compiles, and let's just run it. Cool, so this is the linked list that we were after. So let's just add something out and see that if that also works. So let's just do this, yeah, and compile and run, right? So this also works. So our linked list, the basic code is working. I hope you have understood the basic working of the linked list in this case, and I hope to see you in the next lecture where we will discuss the time complexity of all these things. Then we'll go ahead and look at different problems that linked lists can be used in, and then we'll go ahead and give you your task. So good luck, and I'll see you in the next video.